So in this episode we're looking at the concept of acceleration. And acceleration, which is a vector quantity, is measured as a change in velocity over change in time. So we can represent a change in velocity as being the final velocity minus the initial velocity over time to be able to calculate that. So let's have an actual example. Let's say we have a trolley on the top of a hill and it's going down the hill and it doesn't have a constant velocity because acceleration, of course, is that change in velocity. Because things get faster, faster, faster as obviously it's pulled down the hill to where it may stop eventually, or where the finish line is as such. So in order to calculate this, let's say that it took 3 seconds for the trolley to go down the hill, and let's say that it started from a rest, meaning a velocity of 0 meters per second. Let's also say that the velocity measured at this final line here was actually 1.8 meters per second. So now, basically what we do with this knowledge of the question, where the trolley took 3 seconds to roll down the hill, it started from rest, and it had a final velocity of 1.8 at the finish line, is we actually rearrange it into the formula. So in this case, t equals 3 for 3 seconds. It's in SI units. So that means that basically it's the general units that we used for conversion, and meters per second is obviously an SI unit. It's our general unit that we use to formulate, and we can convert it if necessary, which I'll show in another lesson where we have some more complex measurements. And velocity initial, where it started from rest, is of course 0 meters per second because it was at rest, it didn't have any velocity. It was just sitting there until it started rolling down the hill. And of course velocity final is 1.8 meters per second. So what is the acceleration? And just before I move on to calculating it, I just want to note that acceleration, and I've said this before, is measured in meters per second, which is represented as meters per second to the negative squared. Now you're probably thinking, well, why is this the case? Now remember velocity that was measured in meters per second? Well, basically, when we have meters per second over time that are measured in seconds, we basically get m divided by s divided by s, and that's how we get it because we're looking at a change in velocity per second. I know that may sound confusing, but it will sink in after a little while. After doing a physics for a bit, it will just snap and you're like, oh, so that's why acceleration is measured in meters per second, because velocity is measured in meters per second, and we're looking at the rate of change per second. So don't worry if you don't get that right away, but it will just snap in one day and you'll be like, oh, I can't believe it. I can't believe I didn't get that before. So anyway, let's have a look at how we would calculate this mathematically. So again, we have this formula, and we want to know acceleration. So again, it's the final velocity, which is 1.8, subtract the initial velocity, which is 0, all over 3. So now, with acceleration, and let's just say that this trolley isn't actually decelerating, it keeps increasing as it's going. This is just a point where we want to measure to. Because if it was decelerating, then we'd have to look at an acceleration phase and then a deceleration phase. But just for this, it'd be 1.8 over 3 meters per second for acceleration. And when we actually look at what that calculates down to, which I'm just quickly calculating now, we basically get that the acceleration is, of course, 0.6 meters per second. So, what we did was we got the formula, change in velocity over change in time. which translates to the final velocity take initial velocity. That's how you measure difference. You take the bigger number and you subtract the smaller number. You'll probably know this from maths before. And then the change in time, so 3 seconds. 3 seconds it took for it to get down there, so that's the change in time. Then we substitute in our figures based on the question. So we said that it was 1.8 at the finish line, and it was starting from rest, so that's 0. And then we divide it by the time it took, which was 3 seconds. Then we get basically 1.8 divided by 3 meters per second squared, because it's the velocity divided by seconds, so again, meters per second to -2. And then we're able to, come to the final acceleration, meaning that the trolley gets faster. The velocity increases by 0.6 meters per second every second. And essentially, this is not how fast the trolley's going every second, but the trolley will get faster, faster, faster to be able to cover this scope. So next episode, we'll use the same example and we'll continue on, but instead of having a look at acceleration, we'll look at calculating how far this trolley actually travelled, because we don't know that. All we know is it's been going for 3 seconds, it's been increasing by that, and basically we don't know how far it's going to go until we use another mathematical formula. So until the next video, I hope this has been helpful, but that's just a brief insight into acceleration. And acceleration, of course, something we do need to add here, is a direction, if you've watched my previous video, because essentially acceleration uses the velocity, and velocity is a vector quantity, as is acceleration, so therefore it's actually 0.6 meters per second downwards. So just remember that, because direction does matter. But anyway, I hope that that's been helpful, and that this sort of covers your brief inquiry into what acceleration is and how you can calculate it. Thank you very much.